we're at the top of the hour, so let's go ahead and get started. Hi, everyone, and thank you so much for joining us today for our Insulation Intel webinar, Myths About Sprayfoam. I'm Rachel Hunt, and I'll be your moderator for today's presentation. Before we dive in to introductions, I'd like to go over a few protocols. So first, I want to highlight if you have any questions or concerns throughout the webinar, you can submit them at any point during the presentation via the Q&A feature. We'll address these questions live at the end of the presentation. If you don't see Q&A to the right of your screen, look for the series of circular icons at the bottom or in the middle of your screen and select the icon with the ellipsis and it'll open a menu with an option for Q&A at the top. Select that option and the dialog box to submit questions will open for you at the right of your screen. And a quick note before we get started, this webinar is intended for educational purposes only and should not be used as a substitute for professional engineering designs, consultation, or documentation that may be required by building codes, contracts, or applicable by law. If you have any questions after the webinar, you can refer to our specific application guidelines and instructions located in the product sections of our website. Additionally, following this webinar today, we will be conducting a survey. And this is your opportunity to provide us feedback on how we did today, ask any additional questions that you might have about the topic or webinar, or even suggest new topics for future webinars. And this survey is also part of how we deliver the JM experience to you. The JM experience is based on 4 pillars of the JM culture, which is listed there in the bottom left corner of the slide. We believe it's critical to make sure we hear, understand, and respond to your needs in order to deliver the best interaction to you. And we offer webinars like this one to help educate the market and offer a tool and a resource for you and your business. But we understand that this isn't just a one-way street. So your feedback is a key component to helping us evolve and to make us better meet your needs. So if you have any comments or suggestions as how we can better accomplish this, or even if you feel like we missed the mark today, we encourage you to fill out the survey. We use your feedback to improve our webinars and provide the information that's most valuable to you. Also, we frequently get asked whether or not we send these presentations after they're over. And while we don't send the presentation itself, we do post a recording of it online for you to watch at your leisure or share with your colleagues. And this ensures that you have the presentation within its full context. We also email you it once it's over as part of our follow-up. So with that, I will go ahead and hand it over to Chanel Charbonneau and Wyatt Stevens to introduce themselves. Chanel, I'll let you get started.
Thank you, Rachel. So yeah, I am Chanel Charbonneau. I am a product engineer for Sprayfoam at Johns Manville, and I will give you a couple seconds to write down my contact info. And then also presenting today is Wyatt Stevens.
Good afternoon, everybody. Wyatt Stevens, Senior Field Technical Specialist. At face value, there's a handful of team members within the technical organization. I primarily support the 11 Western states, but I'm available for any questions or commentary or clarification on something that's needed.
So on our agenda today are some Sprayfoam myths relating to building science, chemistry and quality, and then equipment and technical support. So we'll have a few of these for each, and then some additional time for questions at the end. So starting out with building science. So we'll start with the most basic myth that actually underlines many of the other ones. Even though spray foam has been around for decades, you still see spray foam rather than open cell or closed cell spray foam called out on specs sometimes when their properties are vastly different. Beginning at the chemical and microscopic level, closed cell and open cell are different, and these differences give them each strengths and weaknesses. To use a building metaphor, open cell is comprised of framing only, whereas closed cell has windows between the frames that keep air and vapor from passing through. So here's a comparison of Corbin open cell versus closed cell. Open cell is much less dense, expands more as it rises, and uses only water to change it from a liquid into a foam solid. It has comparable thermal and acoustical properties to fiberglass, but it's also an air barrier at a minimum thickness of 3.5 inches. Closed cell is more dense and has a higher R value of 7.0 per inch, and you only need 1 inch of it to be an air barrier and 1.5 inches to be a vapor retarder as well. It uses an HFC or HFO blowing agent in conjunction with water to turn it from a liquid into a foam solid, and these help give it more R value as well. Another thing that sets closed cell apart is that because it's very rigid, it makes the entire wall stronger, whereas open cell will move with the building. So now that we have the basics down, I will turn it over to Wyatt to talk about why you would or wouldn't choose either spray foam product.
Thanks, Chanel. So yeah, one of the things that we come across or see at times is the approach that spray foam is the best solution in all applications. And an example that would be exterior of a commercial building. That's not a place that we would put open cell spray foam. Closed cell spray foam behind some sort of exterior cladding would act as a secondary rain screen. We have another product within our mineral wool lineup that called Cladstone that is incredibly resistant to moisture and can be used as a secondary rain screen. And then you can take something like warm climates where open cell is prevalent, and it's prevalent because in something like Houston, it might reach 35 degrees on a super cold day, it might reach 100 degrees on a super hot day, and we're only pushing 30 degrees from our cooling or heating point, and it really doesn't justify that closed cell application. But you move up into climate zone 7, up in Montana, something of the like, and all of a sudden we're trying to heat a home to 70 degrees, the outside temperature is -5, we're trying to cover an 80-degree delta, and it becomes much, much more important to have that high R value. And then if you take something like, and we'll talk about it a bit more here later in the presentation, but there's also a few things around open cell can absorb water when it gets wet. It is open cell in nature, so it experiences a phenomenon referred to as capillary action, where it will move water through the material. And then acoustic performance, we'll talk about a little bit more as well, but the acoustic performance is certainly much better in fibrous insulations, and so interior sound walls would be a place where spray foam's not really the best solution. Next myth.
Thank you, Wyatt.
Oh, go ahead.
No, sorry. Yeah, so the next one is that buildings can be air sealed too well. This actually comes up pretty often. So the rule of thumb for this one is build it tight, ventilate right. Buildings should be air sealed as much as possible, but it is very important to manage air exchange with proper intentional ventilation that conditions and filters the air. We do want fresh outdoor air brought into our buildings, but not through just random uncontrolled leaks in the building envelope. We want that air to be filtered and conditioned and delivered through clean ductwork. Both residential and commercial building codes call for fresh outdoor air to be delivered to our buildings for good indoor air quality. The residential code calls for an airflow in cubic feet per minute equivalent to 1% of the floor area plus 7.5 CFM per occupant. So that works out to around 75 CFM total for most 3 to 4 bedroom homes. The best way to deliver fresh air is through a whole house ventilation system that includes an HRV or ERV, which is a heat recovery or energy recovery ventilator. These are devices that bring in fresh air and exhaust stale air. The additional benefit they bring is that the exhausted air and the fresh air pass through a heat exchanger, which lets the incoming air be tempered by the exhausting air. The difference between an ERV and an HRV is that an HRV only exchanges heat between the air streams, while an ERV also exchanges humidity. An ERV is usually recommended in more humid climates, but that could also be used anywhere. HRVs and ERVs help reduce the energy impact of bringing outdoor air into the building. So ideally, the ventilation system results in a building that's pressure balanced, so the same amount of air is getting exhausted as is brought in, so we're not trying to force air through any remaining cracks or holes in the building envelope. So again, that's build it tight, ventilate right, and when installed at the minimum thickness for an air barrier, spray foam is an excellent way to achieve the first half of that saying. So kind of continuing on to energy performance, next myth is that R value alone determines the energy performance of your home. So R value is very important, but energy performance comes from a lot more than just that. R value is a measure of how good a material is at insulating. It is product specific and does not describe the actual wall performance because walls include framing and penetrations and so on. When you account for all of that, you are calculating what's called a U value for the assembly, which is a measure of the thermal performance of the entire wall, including framing, sheathing, electrical boxes, and the like. Framing has a lower R value than insulation does, so your total wall U value is less than you expect based on just that R value if you were to just multiply the dimensions of the wall by your R value. So that being said, R value is very important because your insulation is taking up most of that space in the wall, but there's many factors that go into the design of a building that influence energy performance beyond your choice of insulation product. For example, a building designed with better air sealing, which is something that spray foam is very good at, can use a smaller HVAC system and lower your energy usage overall, even when you're just using the minimum code prescriptive R value. Spray foam air seals where it's installed and therefore can reduce energy consumption when installed at the same R value as a non-air barrier insulation. There's a lot more than just R value to take into account when looking at energy performance, but the building envelope is a great place to start since it does dictate so many other choices when designing a building, like your HVAC and potential for on-site renewables, for instance. So as Wyatt mentioned, spray foam can have some strengths and weaknesses when it comes to acoustics between closed cell and open cell. So our next myth is that spray foam offers similar acoustical benefits to fibrous insulation. So this one is half true. Open cell spray foam provides acoustic benefits equal to that of fibrous insulations, but closed cell is not nearly as good. This doesn't mean that closed cell is necessarily a bad choice overall when good acoustical properties are desired. What you would do there is use a hybrid system with fibrous insulation over generally 1.5 inches of closed cell spray foam. So you're still getting good acoustical properties, but you're also getting the air and vapor barrier and about R11 just from the spray foam alone. Wyatt will talk more about hybrid assemblies later in the webinar. Another thing to consider when you're building walls with sound in mind is that no one single cavity should have penetrations going through both sides of the wall. Sound follows air paths, so this design is very detrimental to sound control. And this is one place where using spray foam over fibrous insulation is a lot better because it's an air barrier and it'll seal any of those gaps. So I will hand it off to Wyatt to talk about spray foam myths on chemistry and quality.
Thanks so much. So yeah, we'll move on to kind of a second section here and talk about some of the myths that come around chemistry. And then one of the things that we see often is the idea or notion that because a can light might be IC rated, insulation contact rated, that you can turn around and bury that can light in spray foam. This is in fact definitely not true. And what will happen is if that can light is outfitted with an incandescent bulb, it will probably run for no more than 30 minutes at the most before it trips an over temperature switch. Certainly not much of a problem when those can lights are outfitted with LED or CFL bulbs, but an incandescent will certainly happen. There is an in-service temperature rating for, we'll just call it medium density closed cell spray foam, open cell spray foam in general, of 185, 190 degrees. Perhaps through specialty formulations, we could get through 205, maybe 210 at the most. but you're really not going to see a thermal set polyurethane foam that can be installed in direct contact with something that's seeing daily in service temperatures of over 200 degrees. Common application that this comes up on is a boiler that sits outside of a hospital, for example, and then they want to insulate those pipes or do what they call trench foam on those pipes running from the boiler into the hospital. Obviously, by merit of the fact it's a boiler, it means the steam through those pipes is over 212. So just one area to be careful with. There's several other items that come in place with heat-producing apparatus or elements in a building construction environment. The heat flue off of the HVAC or the heat flue off a chimney or fireplace. But with any of those, we want to avoid being in contact over 200 degrees, 185. Go ahead. So looking at cost per set, it's a pretty common myth that really your job cost is fixated on or directly related to what the drum set costs. And one of the things that we want to look at there and be careful so that your job costing correctly is your actual cost per board foot. If you took open cell, for example, that same 1,000 pounds, 100-ish gallons of liquid is going to make 15, 16, 17,000 board feet of foam, while closed cell out of the same 100 gallons is going to make only 4,500, 5,000 board feet of foam. So chemistry comes into play here where really you're interested in knowing what the resulting plastic is. And in order to understand what your actual costs are, it's far less important how much you paid for the drum set as drilling down to what you're paying per board foot for the finished plastic. There's another piece there that often comes into play on open cell in particular, but the ability to control the application and have a nice uniform rise profile, that when you're targeting a 3.5-inch install, you're actually able to control the spray and hit a 3.5-inch install, and you don't have a lot of trim and a lot of waste. In closed cell, having a nice controlled rate of rise that you're targeting 2 inches and you're actually hitting somewhere between, 1 3/4, 2 1/4, maybe as low as 1.5, as high as 2.5, but that your actual average thickness is the targeted installed thickness. There is see, this one's actually for you, I think, Chanel.
Yep, thanks, Wyatt. Yeah, so the next myth is that spray foam cannot be applied in winter. So this is another one where there's a big difference between closed cell and open cell spray foam. Closed cell has summer blends and winter blends to offset the different substrates and ambient temperatures that you get seasonally. So for example, for Corbin 3, if you're applying in temperatures below 45 degrees, you need a winter formulation. And if you're above 75 degrees, you're going to need to go to your summer formulation. So the difference between these two formulations is primarily in the concentration of catalyst, which is going to determine how fast your foam reaction occurs. The winter formula has more catalyst to help it rise faster, so it's not dripping down or off the substrate. Another thing that you can do to control the rise of the spray foam based on your outside temperature is changing the processing parameters on your proportioner. So you can see also on that table, it's not boxed, but proportioner preheat temperature and hose temperature, those are pretty big ranges. So if you're having temperature swings throughout the day, or if it's just more mild outside, those are things that you can control just, in the moment, change them as much as you need to throughout the day to adjust for the different temperatures. So on the other hand, open cell spray foam does not have a winter blend, just since it's not usually seen in really cold climates. For our Corbin open cell, we recommend not installing below 45 degrees Fahrenheit. And again, that's not something that you're going to see nearly as often with open cell anyway, since it's more of a warm climate product.
Thanks, Chanel. I would like to back up little bit there and add to that. It's not captured here in the slide deck, but right along with summer and winter blend spray foams, within our medium density Corbin line, we also have high altitude and low altitude. And one of the things that happens there is as you go up in elevation, the air gets thinner, which means there's less atmospheric pressure. And if you take a spray foam that tests appropriately at, let's just call it a 2-pound density at sea level, if you take that same spray foam up to an elevation of 6,000 to 7,000 feet, that will not be a 2-pound spray foam any longer. And the resulting spray foam may actually end up being much lower in density and having worsened physical properties than had that same material been sprayed at sea level. So we also make low altitude and high altitude formulations so that we're creating a finished product that's correct and respective to the data sheet. So the good old more spray foam is always better. There are certainly some avenues and times in which more spray foam can just simply be worse. One of those is particularly in hybrid applications. What happens within a hybrid application is if it's 5 degrees outside, or if we're looking at this illustration, it's 25 degrees outside and it's 68 degrees inside. So what happens is there's a temperature gradient that occurs across that wall assembly. And respective to the temperature gradient and then the dew point, we want to make certain that we introduce enough foam into the spray cavity that the face of that foam would always remain above dew point respective to that climate zone and conditions. Now, obviously, climate zones are different, conditions are different, and there is a ratio play here that has to occur. But we want to make sure that we're using enough spray foam that we control the temperature gradient within the wall. One of the other things that can happen is if for some reason you end up spraying onto the backside of drywall, as an example. 1/2-inch drywall, 16-inch on center does pretty good. If you move 1/2-inch drywall to 24-inch on center and you start spraying a tremendous amount of spray foam on that, that spray foam has millions of little cells that are closed. And every single day that spray foam is experiencing a cyclic nature where it's expanding and contracting and expanding and contracting. And ultimately that expansion and contraction can overwhelm something like 1/2-inch drywall at 24 inches on center and start to cusp that drywall. And you can end up, creating a wavy wall as a result of having put too much spray foam perhaps at once. There's some ways to combat that. If you were spraying the backside of drywall, you'd want to do a 1/2-inch to a 3/4-inch lift, give that adequate time to cure, something like 20 minutes, then come back and apply an additional inch, wait again, and then come back and apply more if you're needing something greater than a couple inches of spray foam. This one's yours, Chanel.
All right, yep. So this one will be familiar to anyone who attended our high lift webinar last year. There's no impact on performance when installing thick passes versus multiple immediate passes of closed cell foam. So many spray foam manufacturers offer high lift foams that can be installed in one single pass to very high thicknesses. While there is the idea out there that using a single pass this way is more efficient, it also introduces a lot of risk that the product will not be dimensionally stable or perform the same way as multiple passes of the same product would. So installing one thick pass, which we define as greater than 4 inches, can compromise the quality of the installed foam. It might pull away from the framing, which would negate both the insulation and the air and vapor barrier benefits. Installing using multiple passes leads to more stable results, which I think is really easy to see on these pictures, where you're not getting the shrinkage in the center like you are with the single pass. And it does not significantly reduce job site efficiency either, especially when you account for the potential of needing to fix foam that's installed in a single thick pass that has pulled away from the framing, and you have to go back and fix it. So in September 2020, JM presented a webinar on multiple immediate passes. So if you want to know a lot more about this, the webinar and then also a white paper are all on jm.com.
Okay, so everybody on the call, perhaps not everybody, but a majority would be aware that Johns Manville, as an example, is a large manufacturer of polyiso board. And that polyiso board is clearly created inside of a manufacturing plant. And Sprayfoam is just not the case. We don't actually sell Sprayfoam. We sell the two components that go into making Sprayfoam. There's no polyurethane in either one of the drums. Polyurethane is a compound that creates when the isocyanate and the polyol blend combine with each other. And so one of the things that has to be understood and recognized is that the Sprayfoam rig, be it a trailer, a truck, whatever that might look like, is in fact a micro manufacturing plant, and that the Sprayfoam is being manufactured on the job site. And just as everybody has an expectation that when they purchase a 2-inch thick sheet of polyiso board from Johns Manville as the manufacturer of that polyiso board, that if we're having a problem in our plant, we have to hit the big red stop button. And that same thing exists and occurs for job site application and manufacturing Sprayfoam on the job site, where if there's a problem, it's key that the installer recognizes those issues and stops and rectifies whatever the problem is.
So we'll move on to 3rd or 4th generation Sprayfoam. This is another thing that we presented a webinar on. This was earlier this year. So the myth being that choosing a 3rd or 4th generation closed cell Sprayfoam is a matter of personal preference alone. So while you can use a 4th gen Sprayfoam, aka an HFO blown Sprayfoam wherever you want, there are several states plus Canada that have bans in place on 3rd generation Sprayfoams, aka HFCs. As states and countries work to combat climate change, they're phasing out the use of materials that have a high global warming potential, like HFCs. This impacts all 3rd generation Sprayfoams. And then importantly for all of us, at the federal level, HFCs are being phased out under regulations recently adopted by the US EPA under the AIM Act. While the date has not yet been finalized, expect a full phase out of HFCs, so 3rd generation Sprayfoams, in the next few years at the latest. So again, if you want to learn more about global warming potential, ozone depletion potential, and next generation Sprayfoams, we did a webinar on that back in March, and that's online if you'd like to learn more.
So moving away from some of the pieces that are misdriven by chemistry or formulary aspects of the Sprayfoam, we're going to talk about some of the equipment and support Sprayfoam myths. So this one is one that I see a lot, and oftentimes is at the driving decision for what Sprayfoam rig to purchase or what proportion to put in a Sprayfoam rig. And the notion is that if I get a really, really big machine and I put a really big mixing chamber on it, that the end result of that is I'm going to get much, much more foam installed per day. When in fact, it's not a significant influencer on the amount of foam that gets sprayed each day. So a few things is the larger the Sprayfoam mixing chamber, the more often that I see lack of control on installed thickness. So moving to this larger mixing chamber could actually have a detrimental impact on cost savings, anything seen in the form of labor savings because we got off the job 30 minutes earlier would actually be lost in the fact that oftentimes 2 inches turns into 2.5 inches just because the throughput's too great to control. The second piece is that the barrel set's 100 gallons, and if you were to take apologize to anybody that the nomenclature doesn't mean anything, but the mixing chambers have sizes to them, and if you were to take an AR 4242, which a number of attendees here would be familiar with, that mixing chamber would empty a 100-gallon drum set in about 65 to 70 minutes if you were to just leave the gun wide open. Move up in mixing chamber to a 52-52, and you would empty the drum set in about 55 minutes, maybe 50 minutes. Actual time on trigger is about an hour a day. And the single greatest impact on job site efficiency is simply moving from cavity to cavity and being on the trigger itself as much time as feasibly possible with little respect for what size mixing chamber's in while on the trigger. But watching foam rise is by far and wide the greatest impact on job site efficiency. 2 guns on 1 proportioner. For some reason, this has found its way into the spray foam industry the last few years. Fortunately, it's still very, very, very rare. We just want to take the opportunity to dispel the myth early before it becomes an actual problem. But you cannot run 2 spray foam guns off of a single proportioner. So one of the things that an applicator would see as a normal course of doing his work is that the B side pressure tends to run about 1 to 300 psi greater than the A side pressure, which is perfectly fine. All pressure is a measurement of resistance to flow, and the B side is about 3 times thicker than the A side, and the result of that is it takes more pressure to push the same volume out an equally sized port on the B side and the A side of the mixing chamber. So one of the things that happens with 2 guns is that if gun number 1 starts to see a restriction or a buildup on, for instance, say the A side, while gun number 2 is not seeing that same restriction, maybe gun number 1 is being used more readily or more often. The result of that is the added restriction to the A side of gun number 1 is going to result in an easier path of less resistance through gun number 2, and you'll have an increased volume of A side exiting gun number 2 while gun number 1 is restricted. The bottom line is this absolutely cannot be done. And please, if you ever see this, bring a stop to it. Selecting the right proportioner guarantees on ratio spray foam. So there's a lot of things at play when it comes to on ratio spray foam. And while there have been significant advances in technology that have absolutely helped, and our industry has benefited from those changes in many, many ways, one of the things that we want to talk about is not getting complacent over the fact that I'm using the latest, greatest proportioning system that is supposed to somehow absolutely guarantee this on ratio application, and then I can just kind of throw all caution to the wind and relax on my responsibility as an applicator. So one of the things you'll see on this next slide is go ahead. So this is 2 foam specimens off of the exact same job site. And hopefully you can see that well enough on your end that you can see in the lower foam specimen that there's a lot of blow-in cell structure at the interface. So this is an example where the lower piece of foam came off of the blue piece of OSB. And the blue piece of OSB, for everybody familiar with job sites, is when Home Depot or a lumber yard receives a bunk of OSB or plywood, they paint the exterior. So the top piece of OSB gets painted with whatever color to help preserve it. And the end result of that is that's the piece of OSB that's exposed to the elements or the weather. And in this case, that piece of OSB was installed on the home. Spray foam was subsequently sprayed. There's no reason to believe that the spray foam in the lower part of this picture was any different than the spray foam that was sprayed in the next cavity over. They were both on ratio leaving the gun, but because the blue piece of OSB was wet, the water in that piece of OSB reacted with the B-side components or rather the A-side components, I'm sorry, I apologize. The water reacted with the A-side components and blew the cell structure at the interface. And the end result of this is you actually end up with an off-ratio foam because there are B-side components that don't have any A-side to react with. The real point here is that we just don't want to have complacency over the fact that the technology advances remove the element of responsibility from the applicator, and there is no substitute for a skilled installer. Spray foam equipment lasts for years, requires virtually no maintenance. So this equipment is incredibly robust. It really is. By far and wide, the majority of proportioners use a common drive, and then they use positive displacement pumps, and there's just a couple of check balls. They're very rudimentary in nature, and as long as those check balls are working, material supply is good, you pretty much end up leaving the gun on ratio. But there's several pieces that still come into that, and maintenance pieces. On the inbound side of these equipment, there's Y strainers that need to be serviced on a regular basis. Because the A side reacts with environmental or ambient moisture, it can't be left unused for prolonged periods of time. This particular picture is actually taking a machine out of service and flushing out the A side with a plasticizer, such as dioctophthalate, that is removing the isocyanate from the system so that when the machine's put back into service at a later date, there's not crystallized ISO in the system. There are several pieces. There's some wet cup assemblies. There's pressure relief valves. The gun itself requires maintenance, and we just want to take an opportunity to say we can't neglect those maintenance items and how crucial it is to stay on top of those items. And then right along with that is I hear from time to time, you know, I learned through the school of hard knocks, or I hear some absolute devastating stories around somebody's, you know, learning curve in the spray foam industry because they aligned with suppliers that didn't offer technical support or whatever the case may be, but you are absolutely not supposed to be on your own for spray foam. We have a technical services team. As mentioned earlier in the presentation, we're kind of regionally specific, but at the same time, we're available 24/7. And the team members of the technical group all take calls on weekends. If you're spraying and you need that assistance, we're happy to take the call. And we don't want you feeling like you're left on your own. We are available to you on call. We're available online. We're also available on site. And those services are free to JM customers using JM materials. And in addition to those field techs, we also have some architect and engineering group, Jeff Job and a couple others that handle architect and specifications. And we just want to make sure everybody knows that you're not alone in this. And then we'll just talk about some additional resources, and I'll let Rachel walk through those pieces.
Yeah, thank you so much, Wyatt and Chanel. So that wraps up our myths and facts section of this webinar. And before we get into questions, I do want to highlight a few resources that we have available specifically to spray foam too. So the first one I'd like to talk about is our spray foam installer training, which is available for JM customers. And this is, you can access this through jm.com or the Tech Connect resource page. And this spray foam certification course will highlight all of the steps you need to take in order to become a certified installer. The next one I'd like to highlight is our white paper on the efficacy of high-lift spray foam. So we touched on this subject during the presentation, but this document offers a more in-depth explanation, and this is available to download on jm.com. The next resource is The Source, and this is your access to all things installation intel. You can access previously recorded webinars, like the ones that we mentioned today, and there's also a few trainings that you can refer to, as well as some educational pieces like our white papers and blogs. And you can access this on jm.com/thesource. Again, this is a great resource for anyone who's looking for more educational pieces. And then finally, I'd like to highlight again Tech Connect. The Tech Connect team is available to all JM customers online, on-site, and on call. And these experts are here to help with anything spray foam, and that includes installation, troubleshooting, parts and equipment ordering, or even specifying questions. And then the last slide I'd like to highlight is certificate of completion. We will be sending these out to everyone who attended. They should be in your inbox by Monday. You can use this certificate to submit for additional continuous education learning credits. All right, so that wraps up all of the available resources. I'll just go ahead and jump into questions, Chanel and Wyatt. The first one is for Chanel. Using flash and bat for residential, what is the minimum thickness for Corbin 4?
On a hybrid system like that, we would typically recommend installing 1.5 inches of closed cell spray foam, so you're getting the air and vapor barrier benefits of it, as well as the R11 just from the spray foam alone. But that, of course, depends on the code for that climate zone and local area as well. But usually 1.5 inches is a good rule of thumb because that is our minimum for a vapor barrier for Corbin 3 and Corbin 4.
Great, thank you. This next question is for Wyatt. Spray foam is sometimes applied to insulate ducts in attics. How is it possible to achieve a constant thickness in constrained spaces?
Okay, sure. And real quickly, just to back up on that last question, that 1.5 inches is respective to 2x4 walls. There is a ratio requirement there that if you're moving into a 2x6, 2x8, something of the case, whatever the different dimensions might be of lumber, and a 2x4 would be 1.5 inches, and a 2x6 is probably 2. We'd like to see the R value be equivalent in spray foam and equivalent in the fibrous insulation. With respect to ductwork, while it may not be the favorite answer, the reality is that maintaining a constant, consistent thickness probably depends on your definition of consistent. Round ductwork, a large round duct would be pretty easy to stay consistent on. A 10-inch and 8-inch round duct, just from a sheer pattern perspective coming out the front of the gun, it's not going to be easy to maintain uniform application around something that's only 8 inches round. On square duct, metal duct would probably be pretty easy to maintain consistency, but that just comes back to the skill of the applicator. And I guess it would be more to the fact that, okay, let's look at it from the perspective of achieving a minimum thickness everywhere. But we want to be careful with that as well, that if we say, hey, it's a minimum of 1, we'd like to see 1 to maybe 2. We don't want to see a minimum of 1 and thicknesses up to 3, 3.5 or something. But definitely difficult to do.
Thanks, Wyatt. This next question is for Chanel. What is the maximum thickness allowed by the IBC on the inside under the metal deck?
So the IBC doesn't prescribe specific maximum thicknesses for spray foam. That's something that's going to be in your product-specific code compliance report, which is going to be on the product web pages. And that goes for JM products and everyone else's. It's something that you test for different things. Usually that would be a fire test that you're looking at to figure out what that maximum thickness is. But that, and then along with a lot of other critical information, is going to be on your code compliance report.
Great, thank you. All right, Wyatt, can you discuss how the ambient temperature can affect yields and R value?
Sure. Yeah, so it was a little bit touched on as part of the myth, but a little bit with the winter-summer formulation. So what happens is that a huge piece of driving the expansion of the cellularized plastic or the spray foam is through heat and reactivity, and then phase changing that refrigerant from a liquid into a gas. And that's done through boiling point. And so when you start spraying in cold ambient conditions, it does adversely impact yield. And that's why we make the winter blend foam, is so that there's that added catalyst there to drive more heat and overcome that cold substrate. But the bottom line is as you get to temperatures below 50 degrees, there's going to be some reduced yield. And it's always going to be cheaper as you move to extreme cold conditions. While we make a winter blend that could be sprayed on a 20-degree substrate and achieve adequate physical properties and achieve adequate adhesion, it would lose, let's say, $200–300 in yield on the day, and we could have heated that environment for $75 or $80 and actually saved money and had a more comfortable work environment. So there's definitely an adverse impact related to ambient conditions and cold temperatures.
Thank you. All right, Chanel, does the effectiveness of the weather barrier become compromised when the outer skin is removed? For example, when the installer oversprays a thickness and another sub comes along to install paneling?
So that's a really good question. Foam products, even though you're usually seeing them with the skin on them, they're actually tested without that skin. That's cut off for basically all of our tests for the properties that you see on a data sheet. So when you're seeing that it's, for example, that vapor retarder at 1.5 inches, that's without skin. So when you would go along and factor in that skin, it would be actually a lot better. It's just that we don't test it that way.
Thanks, Chanel. This next question's for Wyatt. How much will each type of spray foam shrink?
Okay. So shrinkage is not inherently expected at all. So one of the things that might be misleading is that you see a dimensional stability test and it says, hey, here was the change in volumetric area of the specimen. Those are unconstrained samples. So one of the things that we require as part of the installation guide is that spray foam is applied to a clean, dry, and sound substrate. Clean and dry for purposes of adhesion, sound for purposes of rigidity, and the adhesion of closed cell spray foam supersedes its natural desire to want to deform as a result of the daily cyclic nature of expansion contraction. So I don't expect that spray foam installed 5 years ago, 20 years ago, 40 years ago is going to see any actual change in its physical state, its adhesion bond to studs, substrates, et cetera, as long as those were clean, dry, and sound to begin with.
Thanks, Wyatt. This next question's for Chanel. What is the optimal thickness of each layer in cases of using more than 6 inches of total spray foam in thickness?
So there's a lot of different ways that you can go about spraying these thicker overall, amounts of spray foam. So this is something that we talked about quite a bit in our multiple pass webinar as well. But for JM Corbin 3 and 4, for 6 inches, what we would recommend is doing 3 immediate passes of 2 inches each. So without any waiting time between those passes, if you do 2 inches each, you can get to that 6 inches. Going above that, our limit for our immediate multiple pass method, which doesn't require the waiting time that a lot of products ask for is doing 4 immediate passes of 1.75 inches. That gets you to 7. If you're going above that, you're going to have to start including that wait time between passes. So for example, if you were trying to get to like 9 inches, you could do those first 3 passes at 2 inches each to get to 6, wait 30 minutes, and then do a final pass of 3 inches over the top of that to get your total thickness. So it really kind of depends on, you know, exactly how long it's going, or how long you have to wait between passes, because thinner passes are usually, as I don't know if Wyatt, you really touched on this that much, but thinner passes are going to give you a little bit worse yield. So if you want to maximize yield, it might be better to do 2 thicker passes of 4 inches each, waiting 30 minutes between. That might get you better yield than doing a multiple immediate pass method that requires using the thinner passes total.
Great, thanks, Chanel. Wyatt, this next question's for you. When excess open cell spray foam is shaved off, is there any way to recycle or reuse the wasted material?
So while the industry is actively working on, we'll call it recycle solutions, one of the things to recognize in a half-pound foam is that a solid polyurethane weighs upwards of 65 pounds per cubic foot. And we've taken that same chemistry and reduced the density from 65 pounds per cubic foot to a half a pound per cubic foot, making a open cell spray foam about 0.7 of 1% plastic. So it's 99.3% air. There's not a lot of plastic there. And fundamentally, the idea of trying to work that into some form of a recycling program is proving to be very, very difficult. But we are working on it. I just don't know how feasible those solutions are or will become. As far as some other use for it, there's really not any other use that JM could advocate or help subscribe to.
Thanks, Wyatt. So Chanel, is the 7 R value an aged R value?
Yep, that's aged. Every R value that you see on a product data sheet or on a code compliance report complies with the FTC's R value rule. So those are aged R values. Great,
thank you. Next question's for Wyatt. In warm, humid climate zones, is there any concern or issues with mold growth on spray foam insulation? Is there any testing or info available about this issue?
So, you know, a key word that's used in that question, Rachel, is the word on spray foam. So it's already on the test report, and it's already part of the standardized test method used and outlined in the acceptance criteria for spray foam in conjunction with the evaluation reports, and that's a mold and fungi test. It's an interesting test. Basically, they take the foam specimen, they inoculate with mold spores, they provide the right conditions, moisture, oxygen, the other 2 pieces that are needed for mold to grow besides the food source. So they create the perfect conditions for that mold to grow, but given the cellularized plastic or spray foam only, there is no mold growth. With that said, when you talk about warm, humid climates, okay, you just introduced 2 of the components. Now you need a food source. And the majority of residential construction is wood framed, and wood frame is ridden with mold spores. So one of the areas that closed cell spray foam, as an example, could help with is as a vapor retarder. You do need moisture in order to grow and allow mold spores to actually spawn. You would need moisture, so closed cell spray foam would actually help mitigate that. Managing air intrusion, so it's suspected that 400 times more moisture moves with air movement than through vapor drive or diffusion. And so that concept of build it tight and ventilate right, and stopping air infiltration, air exfiltration is actually a key component to minimizing the probability of mold growth in warm, humid climates.
Thanks, Wyatt. Next question for Chanel. What is the recommended pass thickness?
So this depends on, again, kind of as Wyatt said, with the hybrid solutions on what your framing is and then what R value you're trying to hit. But our maximum recommended for Corbin 3 and Corbin 4 in the US is 4 inches per pass. In Canada, it's actually only 2 inches per pass. And this is not just a JM Corbin thing. It's actually required by Canadian code to not exceed 2 inches in a single pass of spray foam. So it kind of depends on your application, but in the US, maximum of 4 inches per pass, and in Canada, maximum of 2 inches. And then I guess the other side of that would be a minimum pass thickness. There are some, I think this is kind of going away, but there's some idea out there that it's a good thing to heat up your substrate, especially in the winter, with a flash pass of like a 1/4 inch or a 1/2 inch of spray foam, and that'll help the actual pass of spray foam to adhere better since it's already a little bit warmer. And JM highly discourages this method. You are going to get really poor adhesion on that first pass. It's not going to help out your second pass. You might see off ratio foam even. There's just a lot of problems that come along with doing very thin passes on cold substrates. And even when it's not cold, there's just really no good reason to do very, very thin passes of like 1/2 inch or less. So between 1 and 4 inches in the US and 1 and 2 inches in Canada would be ideal.
And a follow-up to that question, how much time should the installer wait between each pass, and does it vary for open cell and closed cell?
Yeah, so that's a really good question too. So for closed cell with our multiple immediate pass method, what we mean by immediate is you spray bottom to top of the wall cavity, and then, once you get to the top, the bottom is probably finished rising and you can go right over the top of it. So if the foam is still visibly moving, then you'd have to wait until it's at its end of rise phase, and then you can do another pass right over it. For open cell, we do see some benefit adhesion from pass to pass when you wait even just 15, 20, especially 30 seconds after your first pass to go and do a second one. When you spray using a multiple immediate pass method for open cell, you're a lot more likely to see a gap between the first and second pass. So waiting just 15, 20 seconds after that first pass finishes rising is really going to improve your pass adhesion and make sure you're not having any gaps between them.
Thanks, Chanel. I think this will be our last question for the webinar, and it's for you, Wyatt. What certifications or trainings are recommended for installers? What about SPFA certification?
We're certainly huge proponents of SPFA certification, and we accept SPFA certification in lieu of JM certification. As already highlighted and talked about, there's the online and in-person certification training for JM, but no amount of training is too much. And if there's ever something that's in your area that you can take advantage of, you absolutely should. Things like these webinars are excellent. And one of the things I wanted to mention and catch is that if you're trying to land on the Sprayfoam page within the JM website, you can do jm.com/spray, and that will just take you to the landing page for Sprayfoam and make it a little bit easier to drill down to that online certification training links. And then we don't actually complete certification through online. There's just a schooling part of that certification that can be completed online, but ultimately there's an on-site portion to that that's required. in order to actually complete and get certified.
Great, thank you both so much, and thank you everyone for attending today. If we did not have time to get to your questions, a JM representative will be following up in the next few days. I hope that you found this information useful and relevant, and if you have any questions, please don't hesitate to reach out to us directly or via the survey that will pop up on your screen directly after this webinar. Otherwise, take care, and I hope you enjoy the rest of your week.
Thanks, everyone.
Ladies and gentlemen, that concludes today's event. You may now disconnect your lines and have a great day.